right. Okay, so go ahead.
So the name of I'm Roger. This is Nick, and our group name is Zap and Roger. So the name of our project is called the Power Plant. The picture you guys saw first. It's not a real power plant. This is the real deal power plant. So first of all, the basis of our project starts with shape memory alloy. It's made of nickel titanium. It's this wire we have here. And what's special about this wire is that when you heat it up to it gets up to a certain temperature, it remembers its shape that it was originally forged at. So what happened was we took a blowtorch, to heat it up and shape it. And then so whenever we run current through it, it'll remember its shape.
Some system requirements that we have is that we use the Nexus board as a memory alloy controller, and it controls the on time of each one, and it also gave us the pulse width modulation of each one. We're going to use the function generator, but instead we just decided to just use the GPIOs and create a square wave, just turning it on and off, and then we ran the square wave through the wires in a sequence, like different programs, whatever you want to do.
So it'd just be to the different outputs of the Nexus board. So we had 4 different configurations, one for each quote unquote leaf, I guess, if you want to call them that.
Alright, go ahead, the next slide. This is our system block diagram. You want to explain this part?
Yes, pretty much. I mean, it's real simple, straightforward with programming wise. We just have one function, and it just runs over and over again. And then this is the order. So it starts with wire 1, and then it'll go to 2, 3, and 4. But then going backwards, it'll go to wire 2, 1, 3, and 4, jumping around. And then so this is our hardware configuration. So coming out of the Nexus board, we're sending out 4 different square waves running at about 15 kilohertz each. And so what happens is 3.3 volts comes out of the Nexus board, and then it runs to 4 different 741 op amps. And those will bump it up to 5.5 to each of these. And each of those 5.5 will be enough to turn on each individual NMOS. And then from there, when the NMOS turns on, it will allow 1.5 amps to run through to the shape memory alloy, and making it raise just like so.
It makes it raise up, yeah. And we use the Nexus board just to control the frequency of the pulse width modulation and the duty cycle, and then how long it stays on. Yeah. So this is our design overview. We use the Digilent Nexus 2 board, the LM741 op amps in a non-inverting configuration. The 4 NFETs that were high voltage, high amps. That took a while to get that going too, because we had some problems with heat sinks and having the drains and the sources connected. Some resistors, and then 4 2-feet nitinol wires. In the software, we use the microblaze processor and the GPIO as our IP cores. Some features that we have that are not found in like your ordinary house plants. First, you can have programmable sequence, so you can do whatever you want. Like, first we had it, okay, 1, 2, 3, 4, and the next thing I did was, okay, well, we changed it. We decided to go like 1, 2, 3, 4, 2, 4, 1, 3, and across, or you can have them all open or all closed, or you can move it around, and you can even shape the wire to whatever shape you want. So if you're tired of the ordinary bow leaf, you can make the leaf whatever size and shape you want, right?
Yeah, you make 3-leaf clover, whatever you want. Just get a blowtorch.
We've tried doing that with the blowtorch too. We got like a weird shaped leaf that was in the size of a pea. And we decided it didn't look natural, so we decided to go with these shapes.
Exactly.
The extra benefit is that it never needs water. So don't add water because it's electric. If you look inside the plant right here, this is our small breadboard, and the Nexus board controls all the FETs and the amps, and then it goes through the wire, and then it goes into the small breadboard actually inside the plant. So there's no motors or no moving parts aside from the wire. It's just everything's just plugged into the breadboard.
So this can be, your soil, if you will, and this would be your water.
It's also customizable too. See, we use different leaves. You can, if you're feeling like a little funky, you can have the fat leaves, or if you want to be light, you can use the thin leaf. So that's plug and play leaves right there. It's another feature. And you can also control the rise and the time, the fall speed of each of these. If you're, if you want a nice ambient mood or anything that's fast-paced, you can change the speed if you like. So future improvements is that right now we're running at 1.5 amps, which is actually a lot of current. So we want to take that down to less current so we can actually have like a little in-home box that you can plug and play.
Exactly.
That.
Ramble patterns. I think you touched on those already. It's just, changing the pattern of having your leaves go up and down.
Yeah, we want an all open and all closed pattern, or even push button control where we would push the buttons on the Nexus board and have them raise and fall. And we also wanted to do Billy Bass, sound activated plant control. So when you talk, the plant would be a singing bush from the Three Amigos, and it would play music. That's next week.
Yeah,
next week.
We'll work on that a little later. We have more time.
Applications. It's a great gift. Mother's Day, girlfriends, Valentine's Day. Everybody loves a plant.
It's also tied in with theme parks, Disneyland. My man Nick right here is going to work for Disney this summer. He might get into all this, doing animatronics, for Pirates of the Caribbean or something like that.
And also indoor relaxation. You just want to chill. Just want to relax. I actually just like leaving it on because sometimes when I'm doing my homework, it moves, but it doesn't make noise. It's the perfect pet. You don't have to feed it. It provides entertainment.
Yeah, but so yeah, we left our demo ongoing. Does anyone have any questions? Yeah, I mean the wires do warm up a little bit, but it's not too bad. You feel right now it's actually pretty warm. So
yeah, the main problem was the FETs and having them overheat. If you're welcome to come up here and touch them, and we had to put heat sinks on them so that they don't get too hot and short out.
Yeah, because at first, instead of having our 4 individual heat sinks, we had one big fat one, and that got real warm real fast when we had 4 of our MOSFETs on there, and then so yeah, that ended up causing us a lot of problems because it wouldn't work individual leaves at a time. Like all of them would jump up and get real warm, so we'd have to turn everything on real quick.
And you can control how fast they rise and fall based upon how much current you push through. Like, so this one will shoot up fast, and then if I reduce the current here, I'm going to reduce the current to like 1 amp, and the next one might not even get up. It's just going to be very, very slow, if anything even happens. So that's another feature right there. Like I said, come on, let's go. So he's barely going, he's going. There he goes, and I can crank him up, and the next guy's just going to shoot right back up. Ooh. So that's another feature right there.
Energy efficient?
And it is not energy efficient. That's one thing that we are working on. So we're coordinating with the Power Engineering Society.
It's green.
Make it efficient, but it is green.
It's green. For the time being, it is green.
It doesn't have a name yet, aside from Power Plant. So
Exactly.
you're welcome to speak to it and listen.
Which you not have a Nikon?
The 9-0 wire.
Available online. Just look it up online. They just goofing around on the internet and found some videos about people playing with it, and we figured we'd give it a shot and try it out. Just ordered some online.
So now you're in business.
Now we're in business.
Now we're in business.
Starts pumping out these bad boys.
We're going to hire the ShamWow guy. He's going to come and sell this for us. So I hope you guys enjoyed Power Plant. It's patented, so I don't want to see you out there somewhere.
Number 1, baby.